Welcome to the DIY Honda Garage channel. This presentation covers DTC P0976, which indicates a low circuit issue with the shift solenoid valve B in the 2017 to 2022 Honda CR-V. The shift solenoid valve B is part of the continuously variable transmission (CVT) system. This solenoid is responsible for regulating fluid flow within the transmission, facilitating shifting and proper gear selection. It's located within the transmission assembly and plays a crucial role in the vehicle's ability to smoothly transition through gear ratios. The DTC indicates issues primarily in the electrical circuit that communicates with the valve, rather than a mechanical fault in the transmission itself. Understanding this DTC is essential for ensuring optimal transmission performance and addressing any related driving symptoms that may arise from this issue. The DTC P0976 denotes an issue with the shift solenoid valve B circuit, specifically indicating a low voltage signal. This problem can severely affect the performance of the continuously variable transmission, CVT, which relies on solenoids to control fluid pressure and ensure smooth shifting. The shift solenoid valve B is situated within the transmission assembly, and it functions by receiving electrical signals from the powertrain control module, PCM. These signals dictate when to open or close the valve, allowing for fluid flow that corresponds with gear changes. If the electrical circuit is compromised, it may lead to faulty shifting, warnings in the dashboard, or overall poor driving experience. Therefore, understanding this circuit's integrity is paramount for diagnosing the issue accurately. The primary cause of DTC P0976 stems from an electrical circuit issue. It's crucial to recognize that this DTC is not a result of mechanical problems within the transmission. The symptoms typically arise from poor connectivity or loose terminals associated with the shift solenoid valve B. Damaged wiring can also contribute to this problem, leading to continuity issues in the electrical signal. Additionally, the diagnostic trouble code is flagged during the vehicle's operation. It invariably points to the transmission control system's inability to communicate correctly with the PCM. Identifying these causes is essential for effective troubleshooting and ensures that we target our repairs accurately. Symptoms associated with DTC P0976 include poor shifting performance, where the vehicle may hesitate or fail to shift smoothly. Drivers might experience a noticeable delay when accelerating, undermining vehicle responsiveness. Additionally, the transmission may become unresponsive under certain conditions, often resulting in a rough driving experience. Warning lights on the dashboard, such as the check engine light, may illuminate as the vehicle's system detects an issue. These symptoms are critical indicators of the electrical malfunction related to the shift solenoid valve B, signaling that immediate attention is required to prevent further damage to the transmission system. The first step in troubleshooting DTC P0976 involves verifying the issue by preparing the vehicle for testing. Initially, turn the key to the on mode without starting the engine. Subsequently, utilize the Honda Diagnostic System HDS to clear the existing DTC. After clearing the DTC, start the engine and allow it to reach its normal operating temperature, indicated by the radiator fan cycling on twice. Following this warm-up period, conduct a test drive by driving in D mode at a speed of approximately 37 miles per hour for at least 10 seconds. Afterward, check the HDS again for any pending or confirmed DTCs, ensuring that the issue has either been duplicated or resolved, thus moving forward in the troubleshooting process. The second step in the troubleshooting process focuses on checking the IG1 mis-sol line, which is vital for the correct functioning of the shift solenoid valve. Start by turning off the vehicle. Then, jump the SCS line using the HDS to prevent potential damage to the PCM. After waiting for a minute, disconnect the PCM connector A, 51P. With the connector detached, turn on the vehicle again and measure the voltage between test point 1 at PCM connector A, number 11 and body ground. If there is battery voltage present, it confirms that the IG1 mis-sol wire is functioning correctly, allowing you to progress to step 3. However, if there is no voltage, further checks for a blown D4 fuse and the integrity of the IG1 wire will be necessary. In the third step, verifying the condition of the shift solenoid valve B is crucial. Initially, turn off the vehicle and jump the SCS line with the HDS, waiting for a duration to ensure PCM protection. Next, disconnect the PCM connector C, 51P. With this connector removed, measure the resistance between test points. Specifically, check the resistance between test point 1 at PCM connector C, number 19, and body ground while ensuring the vehicle remains in off mode. An ideal resistance reading between 10.6 to 13.5 ohms signals that the shift solenoid valve B is operational. If the reading falls within this range, check related service information or consider replacing the PCM if necessary. If the resistance does not meet this standard, proceed to the next step. The fourth troubleshooting step examines the solenoid wire for shorts that may affect the circuit. Start by disconnecting the solenoid wire harness A, 8P connector. With this connection removed, the objective is to check for continuity between test points of the disconnected connectors. Assure the vehicle is in the off mode while conducting this test. Specifically, measure continuity between test point 1 at PCM connector C, number 19, and body ground. If continuity is found, it indicates a short to body ground exists in the Sol B wire, leading to the shift solenoid valve B, necessitating repairs in that wire. Conversely, if no continuity is detected, further investigation is warranted in the following step. The final step in our troubleshooting procedure involves checking the internal resistance of the shift solenoid valve B. Begin by turning off the vehicle and disconnecting the shift solenoid valve B 2P connector. After the solenoid is disconnected, measure the resistance between its male terminals. Ensure that the vehicle is in off mode for this measurement. If the resistance registers between 10.6 to 13.5 ohms, it confirms that the shift solenoid valve B remains in good condition. In this case, investigate for possible shorts to body ground in the SHB plus wire connecting the solenoid wire harness A to the shift solenoid valve B. However, if the resistance reading falls outside this specified range, it indicates a faulty shift solenoid valve B, necessitating the replacement of the valve body assembly to resolve the DTC. After completing the troubleshooting and corrective actions, the final repair verification is a critical step. Start by verifying the effectiveness of the repairs made. This entails rechecking for any stored DTCs using the HDS. Ensuring that DTC P0976 is no longer present confirms that the repair has resolved the issue. Following this, conduct a test drive under the same conditions where symptoms were originally witnessed to ensure that everything functions correctly. Observing a return to normal shift patterns and smooth transmission operation validates the effectiveness of the repair, providing confirmation that the issue has been effectively addressed. To ensure long-term reliability and prevent future occurrences of DTC P0976, implementing preventive maintenance is essential. Regular electrical checks of the shift solenoid valve and associated wiring will help identify potential issues before they escalate. Additionally, it is vital to inspect all electrical connectors for signs of wear, corrosion, or loose terminals that could contribute to circuit issues. Keeping an eye on the overall performance of the transmission can also catch early signs of malfunction. Organized maintenance schedules that incorporate these checks will enhance vehicle safety and performance, ensuring long-lasting function of critical components. In conclusion, addressing DTC P0976 requires a comprehensive understanding of the shift solenoid valve B circuit. The troubleshooting process involves systematic checks, from investigating the initial electrical connection to detailed resistance measurements. Each step must be executed methodically to isolate issues without overlooking any potential cause. Successful repairs must be validated through post-repair diagnostics and test drives to confirm the resolution of symptoms. By fostering a proactive approach to preventative maintenance, you can help ensure that such DTCs are avoided in the future. Overall, diligent work on these electrical systems can significantly improve transmission performance, thereby enhancing the driving experience. Please like and subscribe to the channel. See you next time.